Hi, I'm Dr. Favia, and welcome to Kinesio Tape's Journal Club. A question I get asked frequently is, does research exist on Kinesio Tape? And my answer is always a resounding yes. When you search Kinesio Tape on Google Scholar, over 13,000 results pop up. If you use PubMed, which is a search engine for scientific articles, over 1,000 articles pop up. So there is plenty of research that has been done over the last few decades from all over the world. So to share that research, I'm starting a Kinesio Tape Journal Club. But first, let's go over what a journal club is. Typically, it's done in person, pre-COVID, but it's an educational meeting where people get together who have read the same article and they discuss that article. There are many purposes to running a journal club. One, it is nice to keep people up to date on the latest research. It also teaches people how to critically think about research, how to tear apart a journal article, how to find the strengths and weaknesses in a research study, so that helps you make better research in the future. And for me, the most important part of a journal club is taking the information that you got from the journal and then translating it to your real life work. So that is the key part for me as a physician. Generally, when you're presenting a journal club, there are 1 or 2 people who present the article. And ideally, everyone in the group has read it, so you can have a more meaningful discussion. The presenters will go through the entire article from the first page to the last page. They will go over the introduction, the hypothesis, the methods, the results, the discussion, and conclusion. When I'm reading a journal article, I pay close attention to the hypothesis to make sure that there is a hypothesis and to know what I'm supposed to be thinking about. And I look closely at the methods section, because in the methods section, you can see their study design, see if there are any flaws or bias that could have affected the results. So the first step in conducting a successful journal club is picking a good article. But as I mentioned earlier, on Google Scholar, there are 13,000 articles to pick from. So how am I gonna pick one to share with y'all? Well, there are many different types of scientific studies, and they have different levels of evidence. So the different studies are interviews, surveys, case controls, randomized controls, cohort, cross-sectional studies, case reports, case series. There's even more than that. So there's actually a pyramid of strength of evidence for these studies that shows you which ones are the top strength levels and which ones are the lowest level in strength. I like to say that the whole pyramid is important from the top to the bottom. So at the top are often reviews. They are meta-analysis reviews, systemic reviews. Sometimes those terms are used interchangeably, but they're actually not the same thing. They're both high-level, strong evidence reports that we use very much in the medical field, but they are slightly different. So in both of them, you're going to be looking at other studies that people have done, smaller ones, and then you collect them all based on their participants. So hopefully that they're all very similar so that you can come to the same conclusion. In a meta-analysis, you'll take all those similar studies and you'll actually take their data, combine it, and use stats to see what the outcome is, to see what the conclusion is. And it kind of creates a summary of the results, but using stats to make a conclusion. So that is a meta-analysis. A systemic review is also where you take many papers that have very similar participants and you try to answer a defined research question by using all those papers. So hopefully when you have like 20 papers all studying the same thing, hopefully they'll all say the same thing and you can make one really strong conclusion. Or if they don't say the same thing and they say different things, you can say, well, the data is inconclusive. Or you can say, all these studies show that this treatment doesn't work, so you don't need to do it. So that is the very top of our pyramid. But neither of those are experimental studies. So experimental studies are what's next in our pyramid, and the gold standard for those are randomized controlled trials. These show cause and effect. Usually, people are put into 2 to 3 different groups, and they are allocated randomly. So there's no picking like, oh, my friend Joe is going to get the treatment, or I don't like this person, so they're not going to get the treatment. That's not how it works. There usually is a computer system that randomly allocates the participants into the different groups. Often the groups are comparing standard of care or no treatment to people who get a new treatment, or standard of care plus a treatment. So if you have in group A people who get the usual treatment, in group B you'll have people get the usual treatment plus the new thing you are studying. A high quality RCT is double blinded. What I mean by that is that the participants and the doctors running the study do not know who's in which group. So this decreases the bias among the participants and the doctors, creating a high level of evidence. After RCTs in our pyramid, there are cohort studies. So in this study, groups of people are studied frequently over a long period of time, typically years, sometimes 10 years, 20 years, 30 years. The 2 groups of people have been exposed to different things. So this is kind of like comparing smokers to non-smokers and then following them for decades to find the incidence of cancer among the 2 groups. In the cohort studies, there are actually 2 types, prospective and retrospective. So prospective is looking towards the future. So in our prospective cohort study, the disease you're looking for has not occurred yet. Like I just said, with the smokers and non-smokers, you just have 2 groups of healthy people, and you just kind of ask them, do you smoke or do you not smoke? And then based on that question, you put them in their 2 groups, and then you just follow them along. Like, do you have cancer in year 1? Do you have cancer in year 2? Do you have cancer in year 3? So you do that for a long period of time, and you can figure out the incidence of diseases. It doesn't have to be cancer. It can be whatever you're looking for. Below cohort studies are case control studies. Now these are just retrospective studies where you're looking in the past. These compare people who have a disease and those without a disease. And then you kind of go back in time looking for a risk factor between the 2 groups. So ideally, these 2 groups of people are nearly identical, except for the fact that one has the disease and one doesn't have the disease. So you would look at people who all live in New Mexico, maybe men around the same age, 40 to 50, who are all tall. And then you want to see like half of them will have one disease, say like psoriasis, and the other half won't have the disease, psoriasis. And then you go back in time and say, oh, all these people who got psoriasis were exposed to this, or the people who didn't have psoriasis were exposed to that. So that is a case control study. Below that are cross-sectional surveys, which is what it sounds like. It's a survey. So you can send out a survey to random people, and you can ask them for information about something for one period of time. So you only get one data point. So in your survey, you can ask, do you have this disease? So you can ask people in New Mexico, do you have heart disease? Do you have diabetes? And then you can find the incidence or how common it is in that area, in that state. How common is diabetes in New Mexico? This is also great for rare diseases, because if you can send out a survey to a whole country, you can find out how many people have that rare disease that maybe if you just surveyed 1,000 people, you wouldn't find. This also is a very cheap study. But the problem is it is very susceptible to bias, because you're reliant on the person's memory. So they have to remember, like, if they have a disease, if they were exposed to this thing that could have happened 10, 20, 30 years ago. Now, at the base of our pyramid are case reports and case series. The definition between these two are a little nebulous. Typically, the defining part is that a case report usually has 3 or less subjects, and a case series has more. This isn't really an experiment. There are no control groups. Pretty much it's kind of, if you have a patient who has a disease and you found a novel treatment that's nowhere in the books, on PubMed and Google Scholar, and you want to share with the world what you've done to help this single or couple people out. That is a case report. And sure, it's at the bottom of our pyramid, but it's so important because they are easy to write and they're a great way to get out your treatment plans to the whole world so they can try it. And a lot of randomized controlled trials start from case reports. So someone writes a case report and then someone else will read it and say like, hey, I want to do that too. And I have the means or resources or the population to do it on a bigger scale. And then that is how you'll get your randomized controlled trial. So every part of this pyramid is super, super important for progressing our knowledge in science. But for our journal club purposes, I'm going to be starting out with randomized controlled trials because they are a good way to show if something works. So people want to know, does Kinesio work? Does it help people? And that is what I am going to be sharing with you in our regular journal clubs. Thank you for joining.